gave us, Lord. There's so many places in the world that we read about and maybe even have been to where there is not that freedom to talk about you, to spread your word, to thank you, to bless you. I pray that we never take that for granted, Lord, but that we also in this class really do that we do question and think about and ponder these things, Lord, in our hearts. Thank you so much for each of the people here. We ask your blessing on Dave as he teaches this morning and on each one of us as we hear him and as we go our way this afternoon. Let us be able to take your love and your knowledge with us. Thank you, Lord. In Jesus' name, amen. Please welcome Dave Sargent.
We do have a lot of people that watch the class recording, and so that will be posted later. So for those that are watching this class recorded later on YouTube, there's a section where you can put comments underneath the video. So if you have questions, you're free to put those there, or even here in the class, you think, oh, I should have asked a question later. You can put that comment there, and I've been monitoring all the class comments and replying to questions that are put there since our biggest audience are people that will watch the class within the next week. So usually live streaming, we usually have another 50, 60 people watch it live, and then several hundred people will watch it over the next week as it's recorded on YouTube. So those people can ask questions. If I see a really good question there, we will be live streaming next week, so also those people that are watching the video, tune in next week for part 2, and of course you can ask your question there. You heard in the introduction that I'm an engineer. People ask me sometimes, what does an engineer do? And the simplest definition is engineers fix problems that you don't even know you have. And so that's what engineers do. With that, Hugh obviously is an astronomer, and I know he did really good because I heard his professor at Caltech say that he was light years ahead of his class. All right, the last time I taught up here, the topic was the big questions of life. And it's one of those that started out with the question of Jesus asked, who do you say that I am? It's the ultimate question that people need to ask. One of the other questions is why is the universe the way it is? And more people study the universe. They teach about the universe in school and classes. My nephews and nieces will ask me questions about the universe sometimes, ask if things that they're being taught are true, because some things they teach just aren't true. They kind of blend in with science fiction. And so this question of why the universe is the way it is a really important question. And so Hugh wrote a complete book on this topic and then lists out different reasons the universe is the way it is. Today is going to be more of an introduction, the first part of that. So tune in next week, because next week we'll actually go down the list of Hugh's answers to this question in detail. So this is the introduction to the book from Why the Universe It Is increasingly astronomers recognize that if the cosmos, meaning the universe and its history, had not unfolded exactly as it did, humanity, people, would not exist. This is also was described now as the anthropic principle, is the scientific definition of this answer. Yet astronomers and a lot of other researchers, even though they see the universe has to be exactly the way it is, resist the belief in a biblical creator. And that's because obviously the Bible describes God preparing the universe for mankind. And so what we see in the record of nature and what we see in the Bible match perfectly. And so why do they resist? And that's probably not only for astronomers, but everyone. A lot of times the most difficult question that people have, of course, is the question of evil and suffering. They say if a loving God had created the universe, why did he make a better home for us, one without trouble and tragedy? Anybody that's lived on this planet long enough has had troubles and tragedy in their life. So in Why the Universe the Way It Is, Hugh draws an in-depth study of both science and scripture to talk about how the universe was designed to fulfill several distinct purposes. And in that book also he reveals how God's surpassing love and his ultimate purpose is displayed for each individual. Stephen Hawking is known for coming up with strong mathematical models and mathematical formulas called the space-time theorems to support the Big Bang model. And he asked this question in a very popular book, A Brief History of Time. We want to make sense of what we see around us, to ask, what is the nature of the universe? What is our place in it? And where did it come from, and where do we come from? And why is it the way it is? And it's interesting that even Stephen Hawking, obviously, was one of the ones that, along with Penrose, came up with these space-time theorems, which are the strongest mathematical formulas to prove that the universe had a beginning, and that the law of cause and effect has to prove that whatever brought the universe into being has to be greater and more powerful than that. And yet he rejected the God of the Bible. And when I read his writings about the God of the Bible, it's interesting that he pictured a God more like Zeus, rather than the biblical God of the Creator. I don't know why he obviously did that, whether he was just ignorant or whether he rejected the God of the Bible, but clearly he didn't understand how big the God of the Bible is. Hugh actually has several videos on that topic. If you search Hugh Ross, how big is God, you could get an answer to this question of that Stephen Hawking didn't miss. Carl Sagan. I actually worked with Carl Sagan. You heard I worked at JPL for 4 years, and at NASA/JPL, we had a love-hate relationship with Carl. We were doing the lander on the moon, and we wanted to get maximum publicity for that, so we invited Carl to come to JPL and to speak about our mission and the excitement about it. And he would do wonderful, great things in his presentation, and the crazy things that he would say on his cosmos. And then he would make just an outlandish comment, that would embarrass him and NASA, and we'd wonder whether we wanted to invite him back. We'd invite him back, and he would do the same thing again. So very interesting fellow. And this was his quote in 85. The universe is a pretty big place if it's just for us. It seems like an awful waste of space. In 1985, I give Carl a little bit of the benefit of a doubt, because in 85, the size, even though the size of the universe and the age of the universe was just becoming known, and the error bars were quite large. So Carl could plead ignorance, obviously, about that. Carl's view of God, he rejected that. He was definitely an atheist, and because of that, he liked the bouncing universe. And in 85, obviously, the bouncing universe model was a possibility. Now we know scientifically it's impossible. There's no way the universe will collapse and rebound. It defies the second law of thermodynamics, and we also know the universe is expanding further and further, so Carl's view of the universe was just wrong. But again, he could plead ignorance. Now, Victor Stenger, this is a much later quote here in 2007. If God created the universe as a special place for humanity, he seems to have wasted an awful lot of space where humanity will never appear. Now, Victor Stenger, on the other hand, he doesn't have an excuse. By 2007, we absolutely knew that the universe had to be exactly as it is for our humanity, for home. So he's either in what I call self-imposed ignorance, or he's just plain old rejected the facts and the truth. He has no excuse, right? Because this is just false, and we'll see why. But it does ask that answer. We still need to answer that question. If an atheist, like Victor Stenger, asks, why is the universe so big? Christians should have an answer, because the Bible and the record of nature give us a clear answer to this. So, the size of the universe. Why is the universe so big? And how big is the universe? Do we know how big the universe it is? And we do, because light takes time to travel. When we turn on the light switch here in the room, it seems instantaneous to us because the distance is so short, and light travels so fast. So light travels at 186,000 miles per second, right? Very, very quick. But the universe is so big that light traveling vast distance takes years to get to us. And so when we look in our telescopes into outer space, all we see is the past, right? Hugh does that joke, obviously, all the time. It says, I only know about the past. As an astronomer, I can't see what's going on in the present. I can only know what's going on in the past, because it took time for that light to get to us. The closest star to Earth is a little over 4 light years away. So traveling at 186,000 miles per second, the light that left that star, takes over 4 years to get to us. That star could blow up right now, and we wouldn't know about it until 4 years from now. And by the way, that star has no planets. So we can't go there. If you go there, there's nothing to do. The closest galaxy to us is 2.5 million light years away. So now we're talking about, millions of years. And then the farthest galaxy that we can see back using the Hubble telescope and the Webb telescope is 33.8 billion light years away. And so that's the observable size of the observable universe. It's 3.8 billion years across, or light years across, very, very distant. And we can see everything in between, right? So we know exactly how long ago the light left these objects to get to us. The furthest we can look back is not visible light. The furthest back we can look at is the cosmic background radiation. And so we can see back to the very beginning of the universe, 13.7 billion years ago. The Hubble Deep Field images are images of the universe just a little bit beyond that. And the background radiation measurement puts the age of the universe at exactly 13.787 billion years, plus or minus 0.02. And that directly corresponds with the first line of the Bible that so many people know. In the beginning, God created the heavens and the earth. Here is one of the Hubble Deep Field images. Every one of those spots of light that you see there is not a star, that is a galaxy. And when the universe was young, it was much smaller, and the galaxies are all packed together very closely. And as we look at the universe closer, in other words, less back in time, these galaxies are now spread very far apart. And so this is one of the ways we can see the age of the universe. We know that the universe is expanding. We know the universe had a beginning, and it had a very hot beginning. So this picture, obviously, that we have here, I have a little description of it, contains about 5.5 thousand galaxies in it, the older of which are 3.2 billion years ago. So all those little small dots you see again are photos. It's so, the light is so dim at these places because the light has traveled such a long distance. They had to have a 23-day exposure to get this image, because the light was so very dim. So these are just photons that have traveled for a very long time to get to our telescope. This is the picture, the most latest photo of the cosmic background radiation. And so we can see that when we look into space, no matter where we look, it's a little bit above freezing, and that's this leftover heat from the creation of the universe. The universe had a very hot beginning, and so we have this heat. The analogy you could use is turn your oven up to 500, 600 degrees as high as it goes. Open the door, leave it open for, whatever, a minute or two, close the door. And if you were to take one of these digital thermometers, if you measure the air that's, in the room, you would see the entire room is going to have heat into it now because that heat has come out there. And you can use mathematical formulas if you know the time that you measure that heat, how long the door was open, you could figure out that your oven was set to whatever 500 degrees. This slight variation that we see in here is really important because this establishes why galaxies form so early. The heat was not uniform. Some places it was hotter, some places it was cooler, and it made the dust and the material of the universe, the gases of the universe, correlate into galaxies. Yeah, is that what he just talked about that? Yeah. It fills all of the space in the observable universe, and it's the remains of the creation universe, because the creation universe started with a very small and very hot origin. From that very small, hot origin, the universe has been expanding. For the first, up until about 9 billion years, the expansion was quite slow because gravity kept the universe from expanding quickly. And after about 9 billion years, the gravity became less, and the dark energy and the space fabric of the universe has taken effect, and now the universe is expanding more quickly. And the edge of the universe, the space curvature of the universe, is approaching the speed of light. So, one of the important things that we've learned, we talked about the history of the universe, the cosmos, is we found out that the mass, the size, and the expansion rate of the universe all must be exactly very fine-tuned for us to have life here on planet Earth. If the universe was any smaller, or had less mass, smaller, there'd be too many black holes and too many heavy elements. In other words, stars would be converting matter into heavy elements at a higher rate, and the rate would be so high that it would poison planet Earth and the whole universe, and we wouldn't have life. If the universe was any larger, it would be cooler, and if it was any cooler, we wouldn't have the heavy elements that we need for life. Right? So we actually need iron, we need radioactive material that's in the core of the Earth we're going to look at. And if the universe was any larger, any cooler, then we wouldn't have those elements for life. And so all of these things, the size, the mass, the expansion, the age of the universe, all must be exact. The mass, obviously, is so fine-tuned now that if you would take in 1 dime of mass out of the early universe, there'd be no possibility of life anywhere in the universe at any time in the history of the universe. So very, very fine-tuned. Not only do we have to have mass, we have to have the right kind of mass. And scientists now put mass into 3 different categories, the right stuff, if you will, of the universe. By the way, I didn't put down. The little P on the bottom you see there is the page number in the book of Why the Universe the Way Is the Way It Is. So, this is a review. This is kind of a bird's eye view, the Reader Digest, the Cliff Note versions of Why the Universe is it is. And if you're interested in learning more about any one of these topics, then you can take a note, you can play it back and see the page number. And if I went to this page number, 37, you would find this chart that I have there in Hugh's book with all the detail about each one of these line items. So this is designed also to be a study guide for you to help you study the book. If you're interested in one particular topic, just note down the page number, and look up the book, and you can find more details. One of the reasons I picked this book, and go to that things, is out of Hugh's book, some of his books are really heavy on science and light on Scripture, and I like this book because it's an absolute balance between Scripture and science. And so it's one of the reasons I picked this. I wanted to go through all of his books, and I picked this one as the first one because it's about half science and about half Bible, and it merges the two together really good and answers that big question, why the universe is the way it is. So the universe we know now is actually made up of 3 different types of things. What we think of mass, we always think of ordinary matter. What you're made out of, planet Earth is made out of, the stars are made out of, and it composes, just a little over, 4.5% of the ordinary matter. But recently we've discovered, obviously, that there's this other thing called dark matter. We can't see it, we can have a tough time detecting it, but we can gravitationally see that it's there. In other words, obviously, that if this dark matter that we can't detect, obviously, and doesn't interact with regular matter wasn't there, then the galaxies wouldn't be the way they are. The Milky Way galaxy, we know, has a massive amount of dark matter surrounding it, and it helps, obviously, keep our spiral arms symmetrical and in the correct alignment so that we can have life here on planet Earth. So dark matter is fine-tuned. If we had more dark matter, it would be bad. If we had less dark matter, it would be bad. So dark matter must be fine-tuned. And then in the space fabric of the universe, we have what's called dark energy. A lot of people obviously get all upset and they say, we don't know what it is, And it's like, well, we know it's there and we know we can measure it. The people that obviously tell me this dark matter doesn't exist, I'm like, well, that's like saying I can't see gravity. I don't understand gravity, so gravity doesn't exist. It's totally silly and nonsense. So don't let anybody, that's typically people that hate the God of the universe, atheists, will obviously make fun of this dark energy, and yet it's very fine-tuned. It's one of the most fine-tuned characteristics. If dark energy was any less, they're going to just 0.1 less, 0.12 more, again, we would have no life in the universe anywhere. And so it's one of the most fine-tuned elements there. And just like gravity, if gravity was next week increase a little bit or decrease a little bit, there would be no life in the universe anywhere. And so these parameters have to be very fairly fine-tuned in order to have the right elements and the right physics of the universe for life to be here on planet Earth. So all this principles of fine-tuned items is not new, even though Hugh's written books and more fine-tuning arguments are developed every week or every month, every year. Freeman Dyson, a theoretical physicist all the way back in '79, realized this. He says, the more I examine the universe and the details of its architecture, the more evidence I find that the universe somehow must have known that we were coming, right? So humans show up on the time scale at the very end, and the universe has been here for more than 13 billion years old. And yet, if the events in the creation of the universe and the unfolding of the universe and the history of the universe had unfolded exactly the way it is, we wouldn't have life here on planet Earth. And so being an engineer, obviously I see that in my work. You can give me a product and I can take it apart and study it, and I can probably tell you what country it was built in without having the made-in country, because obviously the individual engineers from different countries design things different ways. You can tell stuff about the designer by the product that's there. In the same way, when we look at the universe, we can tell distinct characteristics about the designer of the universe, by the design of the universe. And the early universe knew that humans were going to be here because everything is so fine-tuned to give us this place to live for this brief period of time. Hugh has talked about this in the class, and several of his books have articles about this. Is that that Earth in itself obviously is a product of these special fine-tuning of mass, energy, and space, and the elements that it's produced. But the amazing thing about Earth, we've also discovered, is that Earth is in one of the most ideal locations to be able to observe the whole universe. I showed you that Hubble photo where we can see a baby picture, if you will, of the universe when it was only 13 billion years old. That's only possible if you're in a very dark location. And we are in the darkest part of the Milky Way galaxy, in between two spiral arms with not too much dust around us or nebulas around us. So we're in a very dark part of the Milky Way. The Milky Way galaxy in itself is in a very dark location. We're going to look at this in more detail later. And so we're in a perfect place to be able to observe the whole history of the universe. And of course, the Bible shouldn't be a surprise because the Bible declares that. In Psalm 19:1, the heavens proclaim the glory of God, the skies display his craftsmanship. If we were someplace, obviously, where we had more light coming in from, say, a nebula or dust clouds or other stars that were too close to us, the heavens wouldn't be as dark as they are. But when the moon is not up, we can see very far into the dark sky to produce those amazing photos like the Hubble dark field. This one's very interesting because the universe is expanding, because time is taking to change. We have two things. We have the actual universe and we have the observable universe. The observable universe is what we can see with our telescopes, like the Hubble telescope and Webb telescope, seen deep into the past. But the actual universe that exists right now is much larger than the one that we can observe. And that's because light takes time to travel and the universe is expanding quite quickly. And so once again, we can see back. I dropped a 1 here. Should be 13.7 billion years. There's a typo there. And so the universe of the past was much smaller, right? And that we saw that with the Hubble photograph with all of the galaxies packed, jammed together. The universe was much smaller. And God saw what he had made, and it was very good. Given the fixed laws of physics that we have, which means electromagnetism, the strong nuclear force, the weak nuclear force, gravity, electromagnetism, the first and second law of thermodynamics, these laws that govern the universe has just the right size, age, mass, and expansion rate for us to live here on Earth. So we've already seen the universe is 13.7 billion years old, and it's taken the universe that long to produce the elements that we needed for advanced life. So if you go back into time, you can't have advanced life earlier, right? So 10 billion years ago, 5 billion years ago, you couldn't have advanced life on planet Earth. Humans show up as soon as the universe has the right elements to support advanced civilization, humans. But that once you have that advanced life here on planet Earth, you've got to protect it. The universe is a very deadly place. I'm like you when I watch the sci-fi movies. I enjoy them. They're very entertaining. But I know in my heart, I know it's pure science fiction. traveling, to other planets or other galaxies is pure science fiction. Unfortunately, in today's society, as I talked about, just getting from my nephews and my nieces being taught in school, a lot of science fiction that Hollywood produces has merged into actual history, and so we're losing track with reality, correct? So the universe is a very deadly place. Once you pass, if we got in a spaceship as fast as our current technology is, and you got 6 weeks away from planet Earth, there's nothing but death because the radiation there would kill you. And so life is only possible because here on Earth we have long-lasting radioactive isotopes in the center of our Earth that protect us from the deadly radiation, both from the sun and the cosmic radiation coming from other planets. And so outside of Earth is only death. Both NASA and Elon Musk obviously would like to go to the moon, and they're designing rockets to go to the moon, but they don't address the radiation issue at all. They're like, we're just kind of pushing that down the road, and we'll worry about it later. I've had chances to talk with people at NASA. I still have friends at NASA, and tell them, this is ridiculous. You're wasting money designing these things. You've got to address the radiation issue first before you talk about how you're going to get there. Because obviously, it takes about a year to get to Mars, and 6 weeks out, the radiation will start attacking your digestive system, and within a couple weeks you're dead. And if you can't address that issue, there's no sense in talking about leaving Earth. Interesting, when we go to the Earth's magnetic field is so big, when we go to the moon, the astronauts are actually protected by the moon, by Earth, I mean. And here it is. So this is a picture of the Earth's magnetic field. The shape is the side that's compressed. The small side is the side facing the sun, and the sun's solar wind and radiation is pushing on that magnetic field, and then it makes it a trailing off onto the other side. And so the Earth is the largest stable magnet in the universe. The gas giants have magnetic fields on them, but they're not stable. And instead of protecting the planet and protecting its moons, the magnetic field is so strong that it's actually destroying the atmosphere on its moons. But the Earth's magnetic field is very stable. It does move around a little bit. That's been in the news a whole bunch, is the movement of the magnetic field. Originally it was in Hudson Bay in Canada, and it's been moving north a little bit, and some people say it will flip or whatever, and I've had people worry about that. It's not going to go away. The Earth's magnetic field moves around because it's sitting inside of the magma, which is basically kind of like the consistency of a slushy. And so if you put a magnet inside of a slushy and swirl it around, it's going to move. It just moves. It's not a big thing. But this large magnetic field is what protects us from the solar radiation from the sun and from other cosmic rays, particles coming from outer space, and keeps us protected so that we don't die of radiation poisoning within a couple weeks. That center core that produces that large magnetic field and keeps the center of the Earth warm and that magma melted also produces plate tectonics, which is really important for recycling the nutrients. Right? So we're having what they call a Pineapple Express right now, where we have a storm coming from up north of Hawaii day after day, and it's washing nutrients out to the ocean. And if we don't have plate tectonics to recycle those nutrients back onto land, the land would not be able to support advanced life. So plate tectonics is a very important design feature. Hugh jokes a lot of times and says, people say, oh, earthquakes are terrible, and Hugh says, no, on Thanksgiving they give thank God for earthquakes because those earthquakes are recycling nutrients onto land. So we've talked about the age of the universe at 13.7 billion years old. The Earth, we have very accurate dates about this. Hugh, I think just last week, talked about we have a very accurate date for the age of the Earth from 3 or 4 different radiometric dating methods. And the Earth is 4.54 billion years old, plus or minus 0.05 billion years old, about 1/3 the age of the universe. And this wait time is needed again to prepare Earth for advanced life. So if you cannot have life again earlier in the universe, it's just not possible. You don't have all of both the elements that we need for advanced life. You don't have this magnetic field to protect us. You don't have the oxygen that's needed. So advanced life is not possible earlier in the universe. And then Hugh has also talked about it, that we can't have much advanced life much later in the universe. And we're going to talk about that a little bit more later. I have a number of Christians that are young earth creationists. Some of them, I've convinced them to change their view by looking at the Bible. Some are very emotional about this subject. My Christian friends are very emotional about this. It's difficult to talk to them because they get so very emotional, and we'll talk a little bit about why that is. But anytime we bring up the age of the earth, age of the universe, you're going to have to contend with Christians that disagree. On our online streaming, we have a couple people that are young earth creationists, and they watch the show, and I've told them I'm very glad that they're here. But some Christians claim that the Bible empirically says, obviously, literally says that the earth is 6,000 years old. And so the question is, does the Bible really teach this? Where are they getting this from? And the first part is the misinterpretation of the word day in the biblical Hebrew. So in the biblical Hebrew word for day is yom, and when we look through a biblical Hebrew dictionary or a lexicon, it has literally three meanings. It can mean part of the daylight hours. We use that in English. If I say I work on the day shift, that doesn't mean I work 24 hours, right? Could be part of the daylight hours, right? Could be all of the daylight hours, right? So it's light during the day, it's dark at night. That'd be part of the daylight hours. Could mean 24 hours, and of course the young earth Christians are claiming that that's the only way to interpret the word day. Yom is 24 hours. It also can mean a long but finite period of time. And we use that word the same way today. I remember my elementary school teacher telling me that in the day of the dinosaurs, there weren't many mammals. When she said that, I didn't think that dinosaurs were around for just 24 hours. I knew she was talking about a period of time. Or I remember in high school, my dad talking about the Pasadena freeway that leaves out of here, Pasadena, downtown LA. And he drove on that with his dad in his Model T. And he said, in my grandfather's day, the cars didn't go very fast. And that's why this is so curvy. And when my dad told me that, I didn't think my grandfather lived for 24 hours. So in English and in Hebrew, we use this word day the same way. They used it the same way we use it. And so we have to look at other Bible passages to interpret when it says day 1, 2, 3, 4, 5, 6, 7. Are we talking about 24 hours or are we talking about a long period of time? And the key to that is to look at day 7. And this is how I've convinced some of my young earth Christian friends to change to a worldview of this word day being a long period of time. First one is that when you read the text, there is no end to day 7. Day 7 started with the creation of mankind. And Hebrews 4 and Genesis 2 confirm this. The next thing that we see when the Bible talks about day 1 through 6, there's a morning and evening for each one of those. That morning and evening just means the start of a time span, an end of a time span. We still use that same word in English. At my company, we would say the sun's setting on this project, right? We weren't talking literally the sun setting down. We're talking about this project's coming to an end. This time span of this project's coming to an end. Or people would get depressed, and I would sit there and say, well, don't worry, tomorrow's a new day. I wasn't talking about the sun rising. I'm talking about a new time span. We're going to have a new project, something to work on. And we use this word, an Hebrew word, the same way the Hebrews words it, we use it in English. But on day 7, there is no morning and there is no evening. Why? Because day 7 is not ended. And that's exactly what Hebrew 4 says. Hebrew 4 says, 4, 6, 9, and 10 says that we as Christians must enter into the 7th day, enter into God's rest in the 7th day. And so we are in day 7 now. And the record of nature proves that. We have seen no new phyla, no new species or kind, as the Bible describes, come in there. And so if day 7 is a long period of time, then of course day 1 through 6 logically has to be a long period of time also. And then my young Christians would say, yes, but if you look at the genealogies proves that the earth can't be old and that humans have not been on planet Earth for 100 billion years, because we look at the genealogies and we add them all up, they come to 6,000 years. And the problem, obviously, is I tell them to go read the genealogy in Luke, go read the 2 genealogies in Genesis, and tell me why they don't match. And of course, they can't do it. And that's because, obviously, the genealogies are not designed to be a chronological order like we think of our genealogy, right? So they're there rather as a selective look to highlight key figures, either they're people who are really great or really bad, and relationships. And if you look up a Hebrew lexicon and you look up this Hebrew word for father, it is the same word that they use for grandfather. The word is just AV. It's better translated founder of the lineage or ancestor. Right? So it's better to say that the ancestor of David was so-and-so. Doesn't mean it was his father or grandfather. And so the genealogies, I think God purposely made these where they don't match so that we understood that you can't just add these numbers together and come up with a date for Adam and Eve. It just doesn't work. I talked about the young earth creationists get really emotional when we talk about the age of the earth, and they get upset if I say billions. They have a meltdown. And I finally got back to the emotional component of the earth being old to them is that they misinterpret the Bible. And they really just, it's like this Bible verse in Romans 5:12 just doesn't exist in their Bible. And if I quote this to them, they don't even want to talk about it because it's so clear that their position is wrong. Through one man sin entered the world, and through sin death. And so death passed to all mankind. So it tells us obviously that when Adam sinned, death, and that spiritual death and physical death came to people. And they apply that to animals. They say if God is a loving God, he wouldn't have billion years of animals dying, and it's all emotional and it's not based on Scripture. I struggled with a good response besides this one verse to them, and now I've turned it around to them, and they don't have an answer for this one, and I say, well, you tell me that, that if a loving God wouldn't have billions or millions of years of dying animals, and you're telling me that God killed millions of animals because one person did one sin. I said, that isn't a loving God, and of course they don't have an answer for that because it's logically infallible. And so you have to get past, if you're talking to young earth Christians, you have to get past this emotional response to death, and this verse is the one to do it. And then tell them they claim they have moral high ground by saying God is not going to kill these millions of animals, but they don't have moral high ground because they're claiming that one human's act killed a whole bunch of animals. So they really don't have a moral high ground. I put the crow on here because it's very interesting. The very first bird fossil we have right now is a crow. And what is the smartest animal on the planet? A crow. So crows actually lived with dinosaurs if you look at the fossil records. The dinosaurs show up maybe 210 million years ago. Hugh just talked about that last week. The oldest crow fossil we have is 210 million years ago. So a very intelligent animal lived with the dinosaurs. And birds are not dinosaurs. Hugh talked about that last week also. I got a little bit more time here. Hugh's written a whole book on this topic, actually 2 books. Matter of Days is his latest one, and before that he had Creation and Time. So if you're looking for detailed information to talk to young earth creationists about, that's Hugh's book. The best one is The Matter of Days, the most newer one. So the age of the universe, obviously, we have very precise now, right? We've got it down, to 3 decimal places here. And before that, obviously, the scientists loved the steady state model because it got rid of God. So the atheists loved that. The steady state theory was there. In 1929, Hubble came up with his work where he saw the universe was expanding, and if the universe is expanding, that means it had to have a beginning. Famously, Einstein did this mathematically, but then rejected it for theological reasons. And then when the background microwave measurements came in the 1960s, continuing into the 80s, it completely got rid of the steady state theory, as hard as the atheists tried to hang on to it. So the early universe was totally unfit for human life. Again, we had to wait that 13.7 billion years to have humans. There was too much gamma burst. The sun was unstable. It had heavy bombardment to Earth that turned the water into steam. The days were too short. The Earth was spinning too fast. There was no oxygen on the early Earth. There was no landmass on the early Earth. So the early Earth was totally unfit for humans. And that's exactly what the Bible says. It says the earth was formless and empty. Darkness was over the surface of the deep. So that word formless and empty means it was unfit for life and it didn't have any life. And that directly describes what we know the early earth was like. The darkness over the earth, and that tells us the Spirit of God was hovering over the water. That gives us our frame of reference. Our frame of reference is not an outer space looking on earth. It's on the surface of earth. And the early earth looked a lot like Venus with very dark cloud cover and very little light getting to it. And so the reason it was dark, again, was because of these heavy clouds. And the book of Job tells us that. Why such a lonely universe? So Hugh wrote a whole book called Lights in the Sky and Little Green Men. He's writing the sequel to that because we have a lot more information. And so we are alone because we've not found another star that's stable enough to support advanced life. We haven't found a single exoplanet that's able to support advanced life. We haven't found one single galaxy besides the Milky Way that can support life. You have to have spiral stable arms in order to have advanced life over a period of time, and we have not found one single galaxy. So I've changed the people that love Star Wars and claim the universe is full of life, I tell them, I say, tell me one star that can support life. They can't do it. I tell them, tell me one planet that can support life. They can't do it. And they say, tell me one galaxy, right? We've got a catalog of millions of galaxies. Name me one galaxy that can support life besides the Milky Way galaxy, and you can't do it. And so we've looked and looked in outer space, and as I said, outer space is very deadly. The vast distances we just talked about, just to get to the closest star 4 light years away, traveling at the speed of light. We can't travel at the speed of light. If we travel at 10% of the speed of light, you're talking about 40 years to get there, and when you get there, there's no planet to visit. So we're not leaving planet Earth. That's pure science fiction. The scientists, you'll hear these people all the time say, but we found all these places with habitable zones. And I ask them, words have meaning, right? Words have meaning. And when we discuss with people, always discuss the meaning of a word, right? And so what does the word habitable zone mean? Habitable zone means there may be water on that planet for a short period of time. So if you have water on a planet for 15 minutes, they would say that's a habitable zone. Maybe for bacteria, but nothing else is going to live there. People ask me about UFOs all the time. It's a very popular topic. But a lot of times people say, well, you say the universe is a lonely place and that there's no life there because you're a Christian. I say, well, no, the Bible is actually 100% silent on this topic of life on other planets, completely silent. So I say if we found exoplanets and stable stars and stable galaxies out in the outer space, I would say, well, of course, God loves to create. He created life here. He packed this planet with planet Earth. Why wouldn't he pack the universe with life, right? But the universe tells us we're alone. We don't find places for any place to live. And so the question, obviously, are we really alone? And the answer, of course, is really no. God has given us animals. He's given us angels to protect us and to look after us, and God is everywhere. The Bible goes on and on about how you cannot escape God. Can't go to the moon, can't go deep cave, can't get anywhere. You're not going to be able to get away from the presence of God. God is closer to you, than anybody else. So we're in a very dark place in the universe. We already talked about that. Our moon is as small as it can be for advanced life. The moon is perfectly designed for advanced life. If our moon was any bigger or smaller or any closer or any further away, we wouldn't have advanced life on planet Earth. We're in the dark solar system, the darkest place in the solar system, dark star cluster, dark nebula, dark galaxy cluster, dark energy. We're just in the best place to view the universe as the Bible describes. Totally amazing that this psalm very so accurately describes Hugh's profession and the astronomer's profession, that the universe pours out speech every single night, and those that are willing to listen to that speech will find him. It's one of the problems we have now is people live in cities and they're cut off, from the stars that reveal them. So Hugh and I both have the same experience that when we get out of a big city, it's really difficult to find atheists. I'm living in a small town in Wyoming, and I have not found an atheist yet, although I haven't gone to the university, but I plan to see if I can find some atheists to talk to, but I miss talking to atheists, and I have to seek them out in a small town. But here in large towns, it's easy to find atheists. If you want to find lots of atheists, go to a university. At a university, you want to find more atheists, go to the social study department, and you can find almost 100% atheists there. And they're cut off. They don't make it out of the desert. They don't make it out of the cities to see the glory that God has made. Why a decaying universe? And so my wife and I talk about this one a lot. She does not like decaying. She doesn't like housework. She doesn't like things breaking. And so even though she's taken Hugh's class, she's still upset about the second law of dynamics, although she's happy that I'm an engineer and I can fix most of the things that break. I make a living out of the second law of thermodynamics. As an engineer, a lot of my work is repairing things that break. Computers are not going to take over the world because if they're bad, I won't fix them. The engineers just won't fix them. The computers can't fix themselves. Robots can't fix themselves. Robots are designed by humans, right? Artificial intelligence is made by humans. And if we just don't fix the computer, we turn the power off, they get too hot, they blow up. Can they do damage? Yes. They can do good. Artificial intelligence can do good. It can do bad. It's just a tool. And the tool can do good. Our tool can be bad. It's just a new tool. Okay, so the laws of thermodynamics were set down a long time ago, and starting in 1850. And the first law of thermodynamics is that energy cannot be created or destroyed, but it can be converted from one form to another. So if you take a deep breath, the ultimate energy for your breath came from the creation of the universe. I always thought, these things about every breath comes from God was like, just a little, fairy tale, a nice phrase or whatever. And then when I started studying the first law of thermodynamics, it's like, no, that actually is 100% true. The energy that you use to breathe, the energy that you use to digest your food, all came from the creation of the universe. That energy has changed several times through the burning of stars, and then plants obviously using chemicals to make that, but ultimately all that came back. Every molecule in your body, where did it come from? The creation of the universe. Was it processed through stars? Yes. Are you made out of star dust? Yes. And water? Yes. But ultimately, all those elements came from the creation of the universe. The second law of thermodynamics, also called entropy, is defined as heat will flow from hot to cold bodies. I use that analogy of turning up your oven to 500 degrees and opening the door and close it, and your oven's going to get hot, right? Because the heat is flowing from hot to cold. It also obviously says that everything will go from order to disorder or to randomness, will increase in a closed system. And that applies for the universe itself. That's the largest system we have, right? The small system would be this room, the largest system we have is the universe. And the universe is getting colder and colder and is heading towards what's called a heat death, that eventually, obviously, it will get so big that it won't be enough heat for stars to burn. And yet, the second law of thermodynamics, again, is finely designed and fine-tuned for it to have life. Engines work on the principle of the second thermodynamics, obviously, of heat going from hot to cold, making a piston move. And inside of every cell of your body, the second law of thermodynamics is letting you process food and live. And if we didn't have the second law of thermodynamics, we wouldn't have any life. And so this law is perfectly designed. So why do we have decay? Decay is integral to creation. It's physically necessary for us to have life. It's not so high that it discourages from work, right? So if I build something, I build a product, a computer, it's going to last. Hopefully a computer will last, 10, 20 years, maybe longer. So it's not so high to discourage us, but it's not so low as to punish sin, that if somebody obviously we have sinful people on this planet, we're going to talk about later, that the second law of thermodynamics is optimal for restraining sin and restraining evil. And the decay is optimal to prepare us for the new creation. And that's going to be, a lot of that of part two will be heading towards that principle. The universe is heading towards a heat death. We've discussed that already. And 2 Peter declares that the universe will pass away. There'll be a time where this universe will end, planet Earth will end. And scientifically, we know that is true. The universe and planet Earth cannot continue forever. So this is not our home. We're just passing through. It's amazing, obviously, as I told you, that the humans did not come up with the law of thermodynamics until 1850. And yet, obviously, the writer of the book of Romans, most likely Apostle Paul, in 57 AD, perfectly describes the law of thermodynamics to tell us, obviously, that creation is in a bondage to decay, and that we will be liberated from that, talking about the new creation. So it's quite amazing that the Bible, again, is not a science book, but when it talks about science, it's amazing. It gets it always 100% correct. So here we have 2,000 years ago, the Bible directly describing that this universe is in bondage to decay, that is decaying. It will not last. So why do we have decay in this universe? And why do we have evil? And why do we have suffer? The Bible answers these questions. Therefore, we do not lose heart. Though outwardly we are wasting away, but inwardly we are being renewed day by day. So for Christians, obviously, we know our body is decaying. Every day it decays more. I'm getting older, I feel more decay. But yet inwardly, for those that are in Christ, we are being renewed day by day. For our light and momentary troubles are achieving for us eternal glory that as far outweighs them all. When I read this passage just this morning, obviously, I've traveled all around the world, obviously, and I thought about, obviously, how this relates to travel flight. I've driven 2 hours to the airport, standed 2 hours in lines to get on a plane, sat in a small, noisy plane, I even flew back in the day when we were smoking, obviously, in planes. My eyes would be all red. And why did I suffer those hours to get to the destination I wanted to? because I had hope and knew the destination I was going towards was worth the pain and the trouble. And this Bible verse is telling us that if you have pain and suffering in this life, which you will, the Bible promises we'll have pain and suffering, some more, some less, know that it's light and keep your eye on the prize of the new creation. That the pain and suffering in this life is worth running the race, worth the trouble, if you keep your eye on the prize. And we all do that for vacations, have to pack and wash our clothes and stand in lines or drive hours. I drive to Wyoming. It takes me 16 hours to get there. Why? Because I look forward to going there. Why do I look forward to going there? Because my daughter's there, and more than my granddaughter's there. She's so cute. I almost going to put a picture up here, but I didn't. So it's worth the pain and suffering for me to take 2 drives to Wyoming, or 3 days sometimes if I want to, through snow and hail and everything, because I want it, because of the hope of the goal of when I get there. And life is no different, is what the Bible is saying. So without we know that. Doctors know that. Without hope, patients fade away. We have to have hope. And the Bible obviously tells us that we need to have hope, and knowing obviously that this is not it, this is not the end, that there is a new creation and there will be no decay in the new creation. So this universe is a gateway of things. And if you're interested in the new creation, Revelation 21 gives a detailed description. Be aware it's just a word picture. We can't really tell us obviously exactly what it's like. It's a word picture. And we'll just 2 more slides and we'll end. It was interesting. Brandon Carter, all the way back in '83, came up with this term, the anthropic principal inequality. So we talked about this universe is designed for human life, but there's an inequality in it, right? So that the universe took 13.7 billion years to make a home for mankind, and yet we know that humans can only live on this planet for tens of thousands of years. And so this inequality, why is there this long period to make this place for us to live if we only have a small place to live? Anthropic inequality. And when the Bible says God saw what he created and it's good, is God obviously was very pleased with all the work that he did preparing this planet. When I read the first verse of Genesis through, it gives me the picture of a great artist, right? Leonardo da Vinci. He spent years painting the Mona Lisa. And I knew that every stroke he took, he enjoyed making that photo. He liked it so much, he kept it with him his entire life. He never sold it. And when he went to France, he took it with him, and that's where they found it, was with him when he died in France. And so he enjoyed that painting so much and making that painting, obviously, that he kept it with him. And God is the same way, obviously, that is, he's transforming the universe and planet Earth into a place for planet Earth. When he says it is good, he's telling, I enjoyed it. I enjoyed watching animals for billions of years to prepare us for advanced life. And so he's a great artist. And yet there is this inequality. We spent all this time making this place for us, but we're only going to be here for a short period. And that makes sense if this were only passing through, and the goal is to get to the next creation, where there'll be no death, no suffering, and no pain. Hugh has wrote a book, Improbable Planet. I thought I brought it with me. That outlines, obviously, all the things that God did to prepare Earth as a place for humans. So we can view the universe, have the right rotation speed, the right moon, abundant fossil fuels. A lot of the young Earth will say, why? Why would God waste, obviously, billions of years making a place for us? And I'm like, well, you have a house, you have a car, did you enjoy driving here? And where do you think that came from? All that fossil fuel came from billions of years of animal and plant material being buried under the earth and turned into oil for us. And so we prepared that. The sun has to be stable. We've talked about that already. Plate tectonics have to be right. There's a whole bunch of things that have to be just right. All right, we get the microphone up. Go right ahead.
Thank you so much, Dave. It's a really good summary of Hugh's book. That's terrific. I want to remind everybody that we are not live streaming because the internet is down at the church. So I hope y'all have some good questions. And if you don't want to come up to the mic, but you have a burning question, put it on a piece of paper and give it to me, or find me and I'll ask it for you. Our first question is going to come from Mr. Question himself, Doug McComb, who's always first in line. I think he hangs out here during the week, just so he can be first.
When I come to this class, it just makes me realize how much I don't know, so that's why I ask questions. I have two questions, easy question and a harder question. Which do you want first?
Go ahead with the easy one since you said that first.
I'm sorry?
Easy first. Go ahead since you said it. Easy
Okay.
first.
Have you heard about how in solar eclipses, it's just totally amazing that the shadow of the moon blocks out enough of the sun that we can see the corona and all that? What do you think about the timing of all this, where we have telescopes and ways of observing the eclipse? Just by chance, right?
No, it's pretty amazing that that when the sun is obviously very huge, the moon is very small, but because the moon is close, it perfectly eclipses it. And just think about that. Actually, wasn't the case in the past. We talked about obviously going back in time. If you go back just say a billion years, the moon was closer to the Earth, and the Earth spun at a higher rate, and it would have totally blocked out the sun. And so humanity is here exactly at the right time where the moon is just far enough away that it blocks the sun completely. And if we go a billion years in the future, it's going to be the opposite. The moon will be smaller because it is spinning away from Earth. We know that. We put mirrors on the moon when the Apollo astronauts were there, and we use lasers to shoot them up there and it comes back. And every year the moon is moving slightly further away and the Earth is rotating slowly. And that eclipse obviously is great scientifically, obviously, because that actually proved Einstein's theories to be correct. So Einstein's theory of special relativity and general relativity have been proven beyond a shadow of a doubt to be correct. And one of those tests, obviously, was by looking at these solar eclipses, and not just looking at them, but looking at several of them. So it is another amazing divine feature of us humans that we have that perfect eclipse right now for humanity, and that it actually helped us to see that Einstein's theories were correct.
Learned a lot about stars because of that too, right?
Yeah.
Okay.
Yeah.
And here's the harder question. Okay, I'm just totally amazed that we can detect a galaxy 33.7 billion light years away when the universe is only 13.79 billion years old.
Right.
How can we possibly detect that? Is it that there was an acceleration beyond what it is now, but how could we detect a galaxy that far away?
Yeah.
Thank you.
That's a very good question. I get that question from young earthers a lot of times. They say, you're claiming we know the universe is exactly 13.7 billion years old. How can you do that? Your measurements are wrong. And actually, we have several different measurement sticks that we've used to measure the universe, and they all align. So if you go back when Hugh wrote his first book, The Fingerprint of God, the error bar for the age of the universe was quite large. So I was here when he wrote that book. We started Reasons to Believe, and they said the universe was anywhere from 13 to 27 billion years old. And because our error bars was so huge, and we didn't have many tools, the instruments were good. And every year now, the instruments have gotten better, so our error bars got smaller. And then we have several measuring sticks we've used, right? So if I have 4 measuring sticks and they all come up to the same age, then we can very positively say the universe is 13.7. So the two that are the most easiest to understand, some of them are a little bit more difficult. The first one we have is the Hubble photograph that I showed you with all those galaxies packed together. So if we know these galaxies were all packed together in that small space, obviously, when they know the universe is expanding, we can see what the size of the galaxy is here, you can just wind the clock back and know that you're talking about 13.7 billion years. The next one, in 1929, I talked about Hubble was the first one to see that the universe was expanding, had a beginning. Hubble focused his on redshift. And that goes, if you've ever been standing and had a race car or a train go by, you know that the sound changes, right? A race car goes by, it says, it swings by. And that's because those sound waves are building up on you as they come, and then obviously they're getting longer as they go away. And light is no different than that. Light is a wave and it's a particle both. And that wave, if something's moving very fast, it turns from white light to red light. So by looking at a standard star that we know is white, not red, and we look at that same size and standard star, so not a red dwarf, if we look at it close up, it's going to be white. And as we look at it a little bit further away, it's going to turn a little bit more red. And as we look at further away, it's going to turn redder, to the point where it's really far away, that white star is completely red. and so we know it's further away. And Hubble discovered this, and we fine-tuned those measurements, and so we know that. The other one is we look at exploding stars. So if we look at an exploding star, we can use that as a candle, right? And so if it's up close, it's going to be very bright. If it's further away, it's going to be dimmer. And so we have these blowing up stars that are candles. So that's 3 ways we've measured it. And then the last one I already showed you is the background radiation. So that analogy I talked about of your 500-degree oven, you open the door, you close the door, and you can measure the room, obviously, and do the math, and you can figure out how hot that oven was. And so the background radiation is actually the most fine-tuned that we have, obviously, that we number. So the reason we're able to get the error bar down to 0.02 billion years is because that background radiation, we've measured it so precisely that we know exactly how old the universe is. So that's the 4 ways. There's other ways, obviously, but those are the 4 ways, and they all now agree. The error bars all agree, and they've come to that number. And so if anybody tells you otherwise, don't. There was a big thing with the Hubble, the Webb telescope finding early stars and galaxies that they thought were too bright and stuff. Turns out that was just a dust issue, and people merely blew it out of proportion, mostly to get you to click on it and to get you to doubt that. But there is no doubt about the age of the universe. Go ahead.
Okay, so I actually have 2 questions. I'm going to let him go after. I'll give you the hardest one first.
Go ahead.
Genesis 2:5-6 says that God had not caused it to rain on the earth before he made man. That there were springs that would well up from the earth to water the surface of the whole surface of the ground. Please show how that view fits in with the old earth view.
Yeah, that gets quoted. There's some Christians that believe that it didn't rain until the passage that you talked about that. We just know that's not true because the oldest book in the Bible, again, is not Genesis. The oldest book in the Bible is Job, and Job goes into great detail. There's a whole chapters on the water cycle, talking about frost and snow and how God provides food and water for all the animals on planet Earth. And so this was talking about one location. I get this a lot, obviously, with people. One of the presentations I did about a year ago was on weather and climate change and how we know the planet is warming, but it's not your car that's the fault. That America's not causing it. And people will sit there and say, well, yeah, but look, they had one of the coldest days on record in Canada, so it proves that global warming is not right. And I'm like, well, before you make statements like that, you really need to study, meteorology. Weather is the temperature at one place at one time. It has nothing to do with climate. Climate is when you're looking at the weather over a long period of time. And so when you're looking at this verse, it's talking about rain in one particular location at one particular time, and it tells you that the context is the Garden of Eden, which we know now is in southern Mesopotamia. That's where the rivers meet, and it's talking about the rain at that particular time at that particular thing, so it's not really talking about, the whole, anyways, you get the point.
Thanks, Dave. I have a question from someone in the audience here who says, how do we respond to someone who believes in a flat earth? Other than
incredible.
Laughing.
When I was driving here this morning, literally, I was praying that I would not get asked that question. So sometimes, God just, sometimes God answers your questions. Sometimes his answer is, no, Dave, you're not going to get past this one. Because there's more evidence. There's more evidence, that the Earth is old. The age of these there is obviously there. I think what we really ought to do for these people that believe in a young Earth, we ought to get a fund together to put them on airplanes, and because when I was thinking about that, this flat Earth, obviously. I was thinking about one of the most beautiful flight flights I had. Talking about flying in planes is usually not a pleasant experience, especially post 9/11. I've literally flown all over the planet. I've gone to, all the way to the end of South America, to Moscow, all over Europe, all over the place. And the most beautiful flight that I had actually was I took off in Germany at sunset. And then the plane flies out of Germany across England and then flew across Greenland, because that's the shortest route coming to Los Angeles. And because the time that we took off was at sunset, And the Earth is spinning at about 1,000 miles per hour, but the plane is going 500 miles an hour. What was that, 570 miles an hour? And so we were chasing the sun, and so I literally had over Greenland like a 4 or 5 hour sunset. It was the most beautiful sunset ever, right? Because you've got the sun setting off us there, and you've got all the deep canyons and the ice of Greenland. And the plane was, these 747 jets fly very high, almost at 40,000 feet, right? A very high altitude. The thin air up there, they get better gas mileage and less wind resistant, which is why the big super jets fly up that high. And we were high enough, and it was clear enough. That was the thing, there was just no clouds. Usually there's clouds, you can't see anything, but that whole flight was not one single cloud. From, well, I asked you, when you left England, England's always got clouds. They sing songs when the sun comes out. But once we left England, heading over Iceland, over Greenland, it was so high up and so clear, you could see the curvature of the Earth. And that's what Hugh obviously says. Anyone that believes in the young Earth, they just need to get, flat Earth, they just need to get on a plane and fly someplace, because if you fly anywhere more than 5, 6, 7 hours on a clear day, you can literally see the curvature of the Earth. And of course, then you had to ask him, well, if it's flat, how in the world does your GPS device work, and why are we putting all these satellites up there, right? If it's flat, you can just put 2 satellites up there, and we don't need all these, Elon Musk just launched hundreds of more satellites up there so he can provide internet service for every single person on the world. And he's so wealthy, he's actually giving free internet service to places in Africa and poor countries that don't have access to the internet, just out of just his goodness of his heart. He's been losing money on the project, by the way, obviously. If you have this Starlink, he's lost billions of dollars on it, but he's so convicted that everybody should have access to the internet and information that he's putting these satellites up there at his own expense. So there's just plenty of evidence that the Earth is round. The satellites are just getting on a plane. It was the most. Typically, the other problem, obviously, is you have to get to the Apollo landings because they all claim the Apollo landings are fake, obviously, and that's just not true. I already talked about the mirror. So we have 6 mirrors that are put on the moon by the astronauts. And at the time, the lasers weren't powerful enough to shoot these things, but what we do now, obviously, to measure the distance from here to the moon, is they have a very powerful laser next to a telescope. And the telescope looks at this mirror. They turn on a laser. The laser leaving Earth is about the size of your finger, and by the time it gets to the moon, the laser is 1 mile in diameter. But the mirror is about this big in the middle of that diameter, and it reflects that light back to the telescope. And so we just put the telescope on that mirror, you pulse these lasers, and you can pulse it out there. And again, light travels at, everybody should know this number, 186,000 miles per hour, right? And so that light travels there, hits the mirror, and comes back. So we measure that time it takes to come there, divide it by 2, and you have the distance here to the moon, which is why we know that the moon is spinning away. It's getting further and further away from planet Earth every day. And so the moon landings obviously aren't fake. The last one I had a young Earther I had to talk with this last week, and he was like, "No, look at the photos of the moon, and if you from the moon on Apollo, and the sky is black and there's no stars there." And that proves it was fake, right? Because they couldn't put all these little teeny lights in the studio. And no, the reason there's no stars on any of the Apollo photographs, obviously, is because there's no atmosphere. The sun is so bright that they had to turn the aperture down on the cameras so far that the stars were too dim to show up in the photos, right? And so that's why there's no stars in any of the photos there. It's just too bright. It's so bright, obviously, because there's no atmosphere. The big, bulky suits the guys wear, the reason they wear those, if you're on the moon and you stand there in a suit without that big pack on the back, your front side is 1,000 degrees and your back side is a minus 200 degrees. And so what that big pack on the back has got a huge battery, and it has antifreeze. And they got little tubes that go through the suit all the way to the tip of their fingers and their toes to take the heat from their body on the front facing the sun and put it onto their back. I had the pleasure of meeting one of the Apollo 17 astronauts at JPL. And I asked him, I said, weren't you ever afraid, that pump failed or your battery would go dead and, when you would boil and stuff? He says, no, we actually trained for that. He says, if the pump stopped working, if one side started getting too warm and the other side getting too cold, he says, we were told just to walk in a circle, and that way, this part would get warm, this part would get warm. He said on all the missions, none of the packs ever failed. They never had to do that, but they weren't worried about their suit thing. The suits were also very thick, so they did cut the outer layer on rocks several times, but they had 3-4 layers. It wasn't Kevlar because it wasn't invented yet, but very thick material. So he wasn't worried about losing his air either. So so I asked him what his greatest fear on the moon was. Because the greatest fear is the lander was built so lightweight and so thin that parts of it was the thickness of 3 sheets of aluminum foil. And he just knew he was going to slip and put his foot through the side of the spacecraft, and then he'd be stuck inside of his uniform, his suit, and not have to be able to take his helmet off. That was his greatest fear. He said everything else I wasn't worried about. Go ahead.
Hello, David. Can you understand me with the mask on?
Yes, go ahead.
Okay, good. With regard to your comments on AI and your disdain for computers and so on, because you were talking about
I don't disdain them. I've made my whole life on them. I have lots of retirement money
they
because the years of
burn
fixing them.
up and then you have to fix them. And this
Yep.
Anyway, with regard to the law of decay, second law of thermodynamics,
Yep.
entropy, all that, the argument has been made by creationists that is one reason why we should not expect living organisms to self-assemble, because things tend towards decay and disorder instead of increased order. And the retort to that from the naturalist community is that, well, in isolated areas, with various energy inputs and so on, you can get brief interruptions in that general law. Okay, so that's just laying some groundwork. I'd like to ask you, with regard to AI, since it's generally thought that we will have increasing sophisticated AI, that eventually AI will be building its own increasingly sophisticated artificial intelligence, increasingly capable, increasingly complex, that seems to fly in the opposite direction of the law of decay. Now, so this is a hypothetical question. If that were proven to be true, and as the doomsayers say, if rapidly we have this, logarithmic increase in artificial intelligence and it comes to overtake the earth, etc. If that were true, does it not argue that evolution could have occurred in these isolated cases, because it follows that same model, that in isolated areas, given the right conditions, that evolution could occur?
Yeah, well, I'll give you the summary on that. Fuzz, who's one of the scholars Fuzz Ron is a scholar at Reasons to Believe, wrote a whole book on this topic calling Life in the Lab. And so one of the things that they've been doing in the lab is working to try and create life in a lab by putting these amino acids together and trying to assemble, something that looks like, DNA, RNA, although they're not able to get the chains long enough. And he says that they started to do this to try and disprove, the theory that these amino acids couldn't have come together, had to be designed and not come up by random. But their research has actually done the opposite, because it's been the human mind having to get all the right elements, the right temperature, the right material, the purity of the material to produce these little chains of amino acids. And so it's actually a mind that does that. And so where does artificial intelligence come from? It still comes from a human mind, right? And it's worse than that, obviously, is that computers have this adage that we say all the time, garbage in and garbage out, right? I was debating an atheist recently about why we're alone in the universe, and I came up with this thing where I said, well, give me a name of one star, one planet, or one galaxy that contained life. And of course, what does he turn to find that answer? Well, he turns to AI, right? So he goes to his co-pilot or his Google or whatever it is and types in and says what planet has life on it, And of course, then he spits it out, and without doing any research, he spits me the name of this planet, right? And says this planet's definitely got life on it, and AI says that it had life in it. And so then now you go to the star catalog and you look up this star, and the star was an M-class star that has huge flaring, right? If our sun is the most stable star, again, in existence, the flaring is so small compared to anything else. The next closest star has got 10 times the flaring. And so then I asked him, well, where did you get this information from? Well, I got it from the artificial intelligence. And where the artificial intelligence got it? It gave it from a PBS sci-fi. And the artificial intelligence did not understand the difference between PBS's sci-fi as identifying life on this planet and goes into the AI and spits it out as saying there's life on this planet, life is possible on this planet. And so I agree the artificial is getting more intelligent. I read an article yesterday, which is pretty incredible, obviously, the problem with robots is they have to teach them each task individually, and so programming is very difficult. And so they just came up with a robot that learned 1,000 tasks in one day, and he did that by breaking each task into smaller segments and using artificial intelligence to patch those together. But again, that's pretty incredible, but where did that technology come from? A human mind. And so a mind had to create all these amino acids to produce DNA, RNA. It had to be a mind because it's so complex. And the same thing with all this artificial intelligence again. It has to come from a human mind. It has to be maintained by a human mind. Requires lots of energy. You can read stories right now about all the battles where they want to put these AI centers, in a town or a state and community. They're like, well, no, you're going to consume 10% of our energy, and our energy costs are going to go up. So communities are rallying against, obviously, all these artificial things because it takes huge banks of computers that use lots and lots of energy. And of course, lots and lots of air conditioning, right? And so if the air conditioner fails, they could all go bad. If you don't have the power source, or if the power source goes down, it can destroy these things. So this artificial intelligence is consuming lots and lots of resources. All those resources are provided by engineers like me.
Dave, we're out of time. Thank you so much for doing this.
Very good.
Everybody say thank you to Dave.
This is part one. Come back for part two tomorrow. Or next week, next Sunday is part two.
Dave will be back next week. Would you please close us in prayer?
Yes. And then once again, if you're watching this as a recording and if you have questions, like the great questions here, you can put them in the comment section at YouTube, and I'll be happy to reply to those. Dear Lord, we pray that you give Hugh a safe travel back from his time in Florida, and pray that the seeds that he planted there would be fruitful. Pray that the seeds that we plant here in this class would be fruitful in bringing people to a saving knowledge of your love and your grace. Lord, as we go through troubles and trials in this life, which we know we will have, whatever they may be, may we keep our eyes on you. May we keep the eyes on the prize. We look forward to being in the new creation with you where there will be no death, no suffering, and no pain. More than that, Lord, we know that you have given us our Holy Spirit as a seal, as a guarantee of this new promise, of this promise in the future, and that, Jesus, you will walk with us side by side through the troubles of this life and be with us. I would pray that we have a wonderful week, and it's wonderful to be with you, and it'll be wonderful to be even closer to you in the new creation. Amen. Announcement. I also have 3 flyers on the table back here. We're going to be covering them next week, but if you'd like to get a sneak preview, I have 3 flyers on there on suffering, evil, and barriers to salvation and God's mercy and death. Topics we'll be covering next week, but if you would like to get a sneak peek, it's on the table. And